till now we have understood how to perform static structural analysis in Ansys Workbench. And while studying that, we have seen different examples that can be solved in static structural analysis. We understood how to solve 3D models, 2D models, 1D models, assemblies. We understood some important concepts like convergence. We understood how to calculate the factor of safety, fatigue analysis, etc. Now, the next topic that we are going to start with is natural frequencies. Natural frequencies, in this chapter we will understand how to perform the modal analysis. Okay, so let us understand what we are going to do over here. So in this chapter we will be performing the modal analysis. The modal analysis is used to calculate the vibrations such as the natural frequency of the system, and at that particular natural frequency, what is the mode shape of the system that we need to calculate using this type of analysis. Okay, so basically the modal analysis that we are going to perform will be used to calculate the natural frequencies and the corresponding mode shape of the structure or the machine component. The output that we get from the modal analysis can be used as an input for a harmonic or a transient analysis. So as we studied earlier, there are three types of dynamic analysis, that is modal analysis, harmonic analysis and transient dynamic analysis. So first we will have to perform the modal analysis, and the results of that modal analysis will be taken into the harmonic analysis or transient dynamic analysis, and then we will perform the respective analysis. Okay. Now in this example, you can see one image over here which shows the modal analysis that we have performed for a cantilever beam. It is fixed at this support, and now we have performed the modal analysis. The first viewport shows the model, and then the other viewports are showing the different vibrations, and at each vibration we can see different mode shapes. So for at one particular vibration, this is the mode shape achieved. Second vibration, this is the mode shape. Third vibration, this is the mode shape. So this is what we will perform in modal analysis. Okay. Now we can use cantilever beams or any other systems to perform the vibration analysis. Whenever we will take an example of a cantilever beam. Whenever a cantilever beam vibrates, at every vibration or at every frequency, it will achieve different shapes. Okay, so whenever, for example, in the previous example, at one vibration, this is the shape achieved. Second vibration, this is the shape achieved. Okay, so this is what we will understand from the modal analysis. The shape of the component corresponding to every frequency is known as a mode shape. So here, when I say that this is a mode shape that we've achieved, you should understand what is the meaning of a mode shape. So the shape of the component corresponding to a frequency is known as a mode shape. The main aim of the modal analysis is to find whether the natural frequency of the component is anywhere closer to the vibrations induced in the component. Okay, so why are we performing the modal analysis? Because we need to understand whether the natural frequency of the component that we are analyzing is anywhere closer to the vibration that are induced in the components. Okay, in simpler words, whenever the natural frequency of the system is very close to the excitation frequency or the frequency induced in the component, then what happens is resonance will get created. Okay, whenever natural frequency is close to the excitation frequency, resonance will get created, and because of the resonance, the model will start vibrating at very high amplitude, and thus it will fail. Okay, therefore, to avoid this resonance condition, we should be able to use some strengthening options to change the frequency. Okay, so therefore, to avoid resonance, either we need to strengthen the component so that the mode shape will change and hence the frequency will also change. Okay, now let us understand what is the meaning of natural frequency. free vibrations of any elastic body is called as natural vibration, and that happens at a frequency which is called as the natural frequency. So whenever a body, an elastic body, is vibrating freely at whatever frequency, that particular frequency is called as natural frequency. The natural frequency is the frequency at which a system tends to oscillate in the absence of any external force, okay, any driving or damping force. So whenever a body is vibrating on its own without any external loadings, that frequency is called as the natural frequency. Okay. So now we have understood what is the meaning of modal analysis, why we are performing the modal analysis, what will happen if we don't consider the resonance, and what is the meaning of natural frequency. So these are some important terms or concepts that you should know before we start with modal analysis. Now in this chapter we will understand how to perform the modal analysis. We will see how to calculate the vibrations, the frequencies, and for those frequencies how to generate the mode shapes. And when we are performing the modal analysis, we will see how to perform free vibration analysis and also free vibration analysis. Okay, so we will be seeing two types of vibration analysis, that is free vibrations and also free vibration analysis. Okay. So for entering into the modal analysis system, you need to add a modal analysis system to the project window. So for doing this, we will come to the Ansys Workbench project window, and now we will add one modal analysis system from here, from the toolbox, and we will drag it to the project schematic window. Or else you can just double click on the modal analysis system and it will get added up. Okay. So this is how we will start the modal analysis. Now that we have understood the basics, now we will go and solve the problems.